when it comes to AI in forecasting, then obviously today, if we see the RE industry, then the biggest use case of AI is, of course, it is there, but the biggest challenge that is there in the industry today is to be able to forecast both on the generation and demand side, to be able to integrate RE. We have reached 40% of the capacity is coming from RE today, and nearly 22 to 23% of generation that is coming from RE. But we have a very ambitious target. We have to reach 500 gigawatt by 2030 and then net zero by 2070. So all of this would require to be able to integrate RE as much as possible. And I think this is where the forecasting becomes really very important. Particularly if I speak from the generator's point of view, the forecasting is important. I mean, both long-term and short-term forecasting are important. Long-term forecasting is required for planning the project, for making investment commitment, ensuring the bankability of the project. Whereas short-term forecast is important for revenue, for important for minimizing the DSM penalties. And as we move forward and more participation in the market is taking place, I think forecasting is also equally very important to be able to participate across different market segments in the power exchange, where it's not possible to revise the schedule, and we should be able to maximize the revenue. I think from the generation side, forecasting is very essential for the returns of the project, for the viability of the project. uh, till now, I think, before AI really has become dependable and big, we are dependent on uh, mostly statistical method, mathematical method. Earlier, I remember that it used to be simple CAGR method or simple method to do the forecast. Then came those applications of time series models like, let's say, ARIMA or something, which helped us in doing all the forecasting, which goes into the input, also into the planning activities. But now, as AI has really become a dependable tool, I think AI can be engaged very gainfully for carrying out the forecasting. AI basically provides us those intuitive models which could establish the relationship between multiple variables that determines the forecast. While long-term forecast is still easier in the sense, although climate change and those aspects are need to be addressed, so where the uncertainty has increased, but intraday forecast and day ahead forecast are really difficult when it comes to electricity sector, particularly both generation and demand side, because the forecast has to be made on 15-minute time block basis, which is definitely a challenging task till now. And going forward, as we are planning to move towards even shorter time block, 5-minute time block, then I think forecasting will all become even more crucial. So in this, AI provides those machine learning models, as well as deep learning models like neural networks, such as let's say RNNs, recurrent neural networks, or LSTM models, long short-term memory models, which now provide solution to do the forecast. Though it require a lot of training, lot of data to be trained on, which is still a challenge. So AI models are there, but AI model is as good as what is the data that it is being trained on. So I think the journey is on here, and with more efficient AI will add a lot of value to this. In this, we did a couple of use cases which are very limited in scope, but I would like to share that. I do not have the slides, but maybe I will explain it. So these use cases are very limited in scope, but I think very useful in doing the forecast. So one use case is related to the forecasting of generation, where we can reduce the error and the DSM penalties. Now, I said these are limited in scope because here we are not really developing a very comprehensive forecasting model, which various QCS are now working upon: big data, weather data, taking weather data from multiple sources, developing those models. But what we did is, very interestingly, what we did is, we took last 3-4 years data, and we looked at the forecast that has been provided by QCS, and then what is the error that is happening, because there is a gate closure of 7-8 time blocks, after which the revision cannot be made. So therefore, can we further improve it by finding out some of the factors which could reduce the error and DSM penalties? So what we did is, we took 3-4 years data, and we developed a machine learning model. We trained the model with the time of day data, the seasonal data, the weekdays and weekends data, and try to train the model to arrive at a adjusted forecast, which could improve upon what the forecast has been provided by QC and reduce the DSM. What we could see is that, I mean, after training of this data, of this model by almost 3 years of data, what we could find is that we're able to arrive at those factors across 96 time blocks during the day. And depending on the time of the day, depending on the season, depending on the month, it is able to predict the factors, I mean, the factors that would apply on what forecast has been provided by the forecasting agency, and further improve our schedule, so that we can reduce the error and the DSM penalties. And we could see that there has been a significant improvement in the DSM penalties. Still a limited scope, because we are not changing the entire forecasting engine. We did it in house, and we tried to create a use case out of that. But what I would definitely say is that, even though it's a limited in scope, so there are enough I mean, there are big scope which is there, where large AI models can be used. On top of the data, we can have LLMs, we can create those comprehensive engines which could help in large decision making. We are talking about predictive maintenance, we're talking about overall generation forecasting, we're talking about load forecasting based on smart meter, as the previous speaker was saying. But at the same time, we can also look at some of the smaller use cases, where these AI models can really come in, add value, and reduce some of the cost, or enhance our revenue. So similarly, there is another use case which I must share, is that when we go to trade in the power exchange, we there are different segments. Obviously, one is green day ahead market, and real time market. So when we have to commit the quantum at the a day before in the day ahead market, then it's very important to be able to have a how much quantum, decide how much quantum to be committed to this market segment. Ultimately, it's about maximizing the revenue, while also minimizing the deviation settlement, DSM penalty. So one use case that we tried and we are quite successful is that we are able to, uh, on the basis of the past uh, price trends, I mean, again, a machine learning model we tried. We trained the model with all the past market data, the demand supply gap. We took the rolling mean average of last 3 to 4 days, so that we capture the recent movement in the price, train that model, and the output of this model gave us the direction in which the price is moving. So it's not giving the exact price, but the model is able to predict that whether time block wise, the price in the green day ahead market will be higher, or the real time market will be higher. And on the basis of that, when we started allocating the quantum, we could see that there has been an improvement in revenue. So this again is another example where the forecasting can be carried out by using the machine learning model. These are very limited scope, as I said, but this can be made comprehensive. the complexities can be added along with them. It can be a combination of models. It can be machine learning model. Added to that, we can have deep learning models, I mean neural network based models. Or we add the statistical, I mean, on the base of it, some statistical model. So I think all of this can be combined to create really the tools that is required in our day-to-day work, apart from solving larger issues, which could either improve our efficiency in terms of reduction in effort, or reduce our cost, or improve our revenue. So uh, 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 so 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 in summary, I mean, I would say that AI is a great enabler today, and not only it's important for the sector as a whole in terms of grid reliability, demand forecasting, load forecasting, being able to plan the system. It also helps significantly in our day-to-day decision, which might include, going forward, the decisions like when to charge the battery, when to discharge the battery, and how all of this can be used to maximize our revenue.